Hello guys, welcome back to a new video. In the last video we have discussed uh, the propagation of the waves, the in phase, the out of phase, and out of phase 180 degree, out of phase 90 degree. If you're not known about all these terms, to check out my last video. And these are very important, as I told you before, to understand the concept of wavefronts, which is our today's concept. So without wasting time, let's get started. uh, Wavefronts is the phenomena of the wave which supports the wave nature of the light, simply. And first of all, we're looking into definition, and then we'll understanding it, what the definition actually means, and just looking into practical examples and diagrams. Okay, the statement says whenever a wave passes through a certain medium, for suppose there is any wave like this, a wave passes through a certain medium. For suppose I've got an air medium, right? uh, Wave passes to a certain medium. There is a wave and there is a medium. Okay, it particles execute SHM. This is simple harmonic motion. Like they are moving into a periodical motion in a particular direction. As the wave propagates forward, the particles of the waves will uh, propagate forward as well. The focus of all the points in the medium having the same phase. Now, just repeating again, the focus of all the points in the medium, or you can say the focus of all the particles, or the focus of all the points in the medium, or you can say the focus of all the points in the air. Of course, the medium we are taking is air, so the focus of all the points in the air having the same phase of vibration, is called as wavefront. Now, to understand what this very last statement, or the ending words say, we need to understand a term which is used in it, that is the same phase of vibration. What does this mean? So just make a concept like wavefront is something which is formed when the wave is moving in a medium, and all the particles of the wave are in the same phase of vibration. And that's why I yesterday explained you why uh, the the out of phase and in phase are important. These are applicable in this thing. Okay, I'm just taking this part, this part in phase. I'm just taking in phase, right? Just copy pasting it somewhere else. Okay, so remember that the wavefront probably gonna form in the in phase, right? They are probably gonna form in the in phase. Okay, let me use perfect pen. They're gonna form in the in phase. The reason, because in phase is probably, you know, say the same phase. The same phase is referred to as in phase. Whenever there's in phase, they are having the same phase. Same phase meaning like the same propagation. If there is a crest, there would be a crest. If you a trough would be there. At point P, corresponding the point P will burn off another wave. These are termed to be said as uh, the, the the in phase, or the corresponding points. And uh, let me discuss into a single wave phenomena to make you guys more clear about it. Okay, uh, I'm just not going in detail right now, but I'm just letting you know that the wavefront are furthermore divided into two parts. One is peripheral wavefront, and the second one, or you can say the plane wavefront, planar wavefront, or spherical wavefront. There are two types: plane wavefront and spherical. Uh, the spherical, of course, the rounded one. They are just making up like this, while plane is like this, right? So. Uh, just remember that we've got two types, and of course you're gonna uh, may have made a concept like this one is plane and they are matching. They probably gonna be the planar wavefront. Before getting into it, I'm just explaining you the diagrams, then we will move in the details of the types. Yes. Okay, here you're gonna see that wavefront, they are in the same phase. The crest would be in the crest, and the trough is, again you're gonna see, let's make a new linkage on this side, and you're gonna see that here this is forming again. This is what I'm saying exactly. The trough are again in the corresponding position. This means that uh, they will develop the wavefronts, right? You can also take an example of wavefront formation as the water, a rock, a small piece of stone is thrown into water and a wave like projection is happened. For suppose, consider this drop in water and consider this stone in water or the ball placed over here. Now in this case you're gonna see that in water the spherical waves is formation takes place. Similarly, over here, this case is the same. The shape of the wave is spherical. Direction of the waves is propagation, or you can say the direction of the waves is perpendicular to the propagation of the wave. And circular wavefront. Now there, the single circle is said to be a single wavefront, and they are formation of a circular wavefront, perpendicular to the wavefronts. Yes, here the information very important MCQs over here that the always the direction of propagation would be perpendicular to the wavefronts. This is being proved on this side. This is the 90-degree angle being made between the propagation and the wavefront. Now here you can see the direction of movement. Now in this thing you can see that on a single wave there are bunch of waves moving, and in this figure you can see that there are two types of wavefronts being formed. uh, the one which blue is also kind of wavefront, the one which green is also kind of wavefront, because the one is these both are very listen that these both are very similar. Thus there is a difference of the axis. One is over y and one is over x, and they are wavefronts. They are plane wavefronts, right? Similarly in this case you're gonna see that uh, this gonna form from this point. We're gonna form away from this direction over here. Yes, this is wavefront, planar wavefront again planar wavefront. So I do hope that you are time by time getting how we are dealing with it. Now here's the important statement: regions in a periodic wave in which the particles are doing the same thing, oscillating the same phase, are leading to the formation of the wavefronts. Wavefronts at the right angles to the wavefront. Sorry, the wave travels at right angle to the wavefronts. I've told you before. Uh, Don't know wavefronts. Okay. There are two types I've explained before: the plane wavefronts, circular wavefronts. Uh, for this, I'm just you know drawing some sort of wave for. Let's take the planar wavefront. First of all, for suppose I'm having this wave, and I'm having this wave, and I'm having this wave. Right? Then, for suppose these are all similar. Now these all will find out this one. They all will find this one. So all these points are corresponding in the same phase, so it is defined at a very large distance from the point source. The spherical wavefront nearly becomes planar. Now when I will go into spherical wavefronts details, I will discuss you how this happens, but remember that at a far distance these the spherical wavefronts will get converted into planar ones, and a line which shows the direction of the light in the form of propagation is termed to as ray. For suppose there will be line determining this direction. This means this is a ray, and this is direction of the propagation direction of the wave. Remember this; these are formed result of the spherical wavefronts. Now, what about spherical ones? This is a light emitting source, and don't get confused on this all stuff. This is just you're gonna be more clear about this concept when you will study the Huygens principle, which we are doing in the next video probably. Okay. uh, this is a circular wavefront formation. uh, don't take the circles very seriously. uh, okay. Yes, spherical wavefronts, when the disturbance travels in all direction. Of course, when this is a circular formation, this means that there is not only planar congruity, there are different particles, and the particles are spread through all the directions. It would be probably in all the directions spreading around, right? And these are all linked, and these are there that much plane, or you can say the planar wavefronts being found. They just form a circle, you're gonna say, and it emits light in the form of spherical wavefronts which convert into planar in infinity. Now these are propagating, and as this gets bigger bigger, it gets short, it gets it's more area, and at infinity it will get planar wavefront, planar. Now here it is circular. So by bringing the Huygens principle, you will get more clear concept about the position of the wavefronts, how are these forming. But this was just a concept like this, something exists like this. And probably we're gonna try to link the Huygens principle with the same lecture which we have did today. So meet you guys in the next video. Till that, goodbye.